And it looks like we are live. So welcome back. Today I'm going to be continuing to work on my virtual machine. So, right now, what I'm going to work on, let me just completely mess that up. In the build.sh, right now we are linking with the math library, and I don't want to do that anymore. So I want to be able to basically be statically linked, right? So if we look at the executable right now, if I build it, and then, yeah, so we just look at TASM, for example. It's dynamically linked, and I don't want that. So I'm going to remove that dependency. Okay, so basically there's two places where we're using it. We're using the pow, yeah. So this power function, we're using that in actually two places. Yeah, because we use it in here as well. So I'm going to implement that, which that will be pretty easy. And then the harder part is the fmod, where we use that for the float modulus, essentially. So I need to implement that as well. So once I implement those, then I can remove the math.h dependency. So that is the goal today. So let's just do that. All right. So I can just implement it at the top here, like in the helper functions, essentially is what they are. So basically, so double, it'll return a double, and then power, I'll just call it power. So we'll take a double base, as well as a double, let's see, double, what is it, what's the technical name for it? I don't know. So I don't remember exactly. Double, so we have that, and then, yeah, let's do number 2 for now, but I will change that. So essentially, we just have to for in I equals 0, while I is less than number 2. Alright, plus, and actually let's make this like that, I think is a good idea. So if we do that, and then, yeah, so we can just do double result equals 0, actually equals 1. And then we can just do something like result times equals base. I think that's how you do that, and then return result. And that might be wrong. I'm not sure exactly. So let me actually let me make a test.c file, and I'll just open that up, and I will just yank this into there, right here, and then I'll have an int main, and basically we will just print f, and then I will print that out, power, yeah, so we'll do 15.0, and then, or actually I'll do something easier, 10.0, and then 2.0, something like that, and then we will see what the result is. So I do have to include TDIO, there we go, and now let me, no, I can gcc test.c show test, and there we go. So if I run that, 100, okay, so that looks right. Now if we switch it around, it should be 1024. There we go. Okay, yeah, so I guess I did it right. So let's see, is there, let me try something like this where we actually have these. Okay, is that right? Let me do 3 power of 10.5. So is it this number? It doesn't really matter if it doesn't work with doubles because we don't use that. Yeah, it is not that. So, because we do cast this to an int, do I have to, if I don't cast it, and then int, okay, that's still even more wrong. So, yeah. It works with ints, and that is what we need. That's what we use it for, actually, in here. So, if we look at where we use it, let me just search again. Pow. Yeah, right here. So, power. Yeah, these are integers. Yeah, it's all ints. So, that's good. And then the native power function, we can just make it use power as well. And it is int. So, I suppose we should cast this to an int when we return it, because the function is a double. Or maybe I should just make it work specifically with ints. Yeah, maybe I'll just make it int64t for now. Int64, just like that, and then accept those as arguments. Since that is what we use. So, and then yeah, and then let me not cast it to an int. Yeah, and let's make this. I'll make it a side field instead. So whoops, and there we go. So let me build this. Power is not a function or function pointer. Okay. Yeah, so this actually is comparing that. So let me just cast this to a size t. So it can't be negative then, I suppose. That's okay. Power is not a function. All right, so I think I need to call this something different. Basically, my pal. That's just what I'll call it. Yeah. So search where we use this, and I'll call it my pal. Oh yeah, because we actually have a variable here, so that is what the issue was. Yeah, so I'll just do that. That is fine. So let's make sure it builds. Okay, and all good. And I can close out of this. So move. Actually, I'll probably use that for the next one. So now, okay. Now, I will actually go ahead and commit that because that is pretty good. Remove dependency on. I just complete dependency on how function. There we go, and I'll push that, and then I will implement fmod. So I don't know exactly how to do that. So let me try to figure it out. Okay, that looks good. So basically, not okay. Yeah, so I'll do. This is actually a float, so we will use this. My fmod is yeah, so it's double. And yeah, so it'll take two numbers. So one and then double and 2. There we go. And then yeah, it will return that. So how do we do modulus on floats? Yeah, let's see if there's an example on how to sort of implement this. Yeah, without using math.h, because that is what we're using now, and I don't want to do that. Yeah, so this is math.h. So I use a remainder. Yeah, so this is floating modulus. Let me just look at some of these. So yeah, this is the fmod that we don't want. Okay. Yeah, so that's invalid. Remainder. Is this okay? So it's two parameters. Okay, let me see. Does that work? Okay, yes, we don't use that. Let me just turn no one, two, just so that we don't get these problems. Okay. But I think it still links with that. So if I get rid of this, it won't compile anymore, right? Yeah, okay. So that is no good. Yeah, so no, yeah, that is what we will need to do. So is there a way to do it without using math.h? Does this have one? So this, okay, that is C++. Yeah, all of these are. So I might have to actually look at something else. Without math.h. Is there something like that? Yeah, so here's fmod. So I might have to look at an actual mathematical implementation of it. So into fmod. Yeah, that's not what I want. Nope. Long. Then fmod. Some value. Okay. So equals that. I don't want Quora. Let's see. efficiency tip. So would this work? I'm assuming it's not super accurate though. Whoops. Okay. Right. Let's see. How does modulus work with widths? Let's see. Can you do that in Python? So like if I open up with Python and then 5.0 mod 3.2. Okay, so that works. Okay. Because I would like to have floating point modulus. Even though I don't think it's really used for anything, but yeah. Alright, then is Python. This is all Python. Okay. Simple. Can I just look at fmod? So is that in here? No. Let's see. Yeah. In math.h. Do we have? Alright, so we don't have that. Perhaps I could. Give me a moment. Okay, yeah, let me do. Oops, no, there we go. So I'll do this. Let's see. Fmod. Something like that on all the .h files. So z equals fmod. So find fmod. So it's defined in there. Let me look at that. Math. Search for fmod. Okay. So okay. So it is okay. Okay, so it's not an actual function, it's a macro. Okay. That makes it a bit difficult. Let's see. Is there, I just want an implementation of it. Yeah, so that is the library. So this is, in C/C++, and it's in C++. So, okay. So truncate. We could probably implement that. Let me go to up here. Let's see. So I think we have that. So return, let's see, num1 minus trunc. And I don't know if we have trunc, so I divide num2 times num2. So does that work? If I build that, yeah, trunc is not defined. So how is trunc implemented? Let's see, so that is truncate, right? Trunc in C. What does it do specifically? Truncates the values after the decimal point. So, okay. So it rounds. So if we cast, it won't work exactly right? Let me actually open a, let's see. Let's open a test.c. And then I want to look at this. So let's see. Void, let's see, truncate. I don't know if that's valid, but so we'll just take a double. Actually, what is this? So this, yeah, okay, double, none. And then, so if we just cast it to an int, it's not going to truncate properly, I think, with negative numbers, right? Yeah, so instead of this, we'll do truncate 2.3. Yeah, and then I will build this. Oh yeah, because this needs to be an int actually. So run that, and then it's 0, 0. Okay. Yes. Actually, let me long, yeah, like that. Okay. Yeah. So it's 0. So that doesn't work. So is there like an implementation of this? So yeah, that truncates that. But turns a double whose value is after the decimal point is 0 only. So it basically just takes the first one. Okay, but keeps the sign. Let's see. Yeah, so that is okay. So how could we do that? Okay. I will just work with int right now. Actually, I'm putting it as a float, and I want to compare it as int here. Okay, so 2. So it does do that. Yeah. All right. I was wondering what, but if it's negative, then it. Oh, okay. Yeah. So is that valid? Just casting it then. Okay. Well, let me look at this. So 2.0. All right. Input. Yeah. So negative as an 8.8, and that should become that. Okay. I think that might be good enough. Let's see, 4351.5, and it should become 4351. Okay, and positive as well. Okay, yeah, so that's fine, I think. So yeah, we can just use this, and if I make this an int64t and I cast this, because we don't have warnings, so that's why it doesn't give us warnings for this. Something like that, and then I enable all the warnings. Okay, so, oh, okay, I don't think int64t is undeclared, so I need to include that, actually. H, there we go. Okay, and run that, and there we go. Alright, so that is good, so I'll just copy this, actually. And then we have truncate. Okay, and then this can be truncate. Wait, alright. Build this, and there's problems. Okay, truncate. Okay, yeah, so that is actually, ooh. So I don't think it can be called truncate. Is that the issue? My trunk, yes. Here we go. Let's see. So that should be fine, right? Okay. And then I do need to test it and make sure it actually works. But now it does compile, so that is good. So let me just make a test.hasm file. I need to actually create it. And then open it up. Test.hasm. There we go. Okay, and then I will just push 1, push 2. Actually, I need to make it floats. 2.0. Yeah, I'll do something like that. And then mod f. And then print. So I think that is right. Okay, and as float is 1.2. So is that right? Is that right? 2 mod 2.3. 1.2. Okay. So yeah, if I swap them around, so I can just swap, then 1.1. Okay, and that, well, rounding error, but yeah. So that looks good. Now we have mod f. That wasn't too bad. Just copied the solution off the internet, but that's okay, I think. Okay, so that's working. So that is pretty good, actually. I thought it would be a bit harder than that. Let's remove test. Yep, all right. There we go. And now we don't have any of the test.c. Oh, we do have the test, though. The executable. So let me quit out of this. There we go. And then I will commit that. Let's see. So remove dependency on fmod and implement it with my shell. show. There we go. So I will push that. Okay. So let's see. All right, perfect. So something that I did off stream. If we look in, let's see, yeah, I can go to test actually. In print int example, for example, we have entry point. We did have these before, but the problem with it was that it was essentially just a jump. So it just compiled to this essentially. Well, actually, that's exactly what it did. And so if we included libraries, we'd have to put it. We'd have to put it above there. But now I made actually proper entry point, so we can do that, and it will still work. We can put it anywhere technically. Yeah, it'll still work. So if I compile it, print int example, Tim, and it works. But if I don't have the entry point, then it does not work. It messes stuff up. So, that's pretty cool. Yeah, now it's a proper entry point, because before we had them, but it was just jump. So, proper entry points. And it's pretty simple how it actually works. So in the Lexer, lexer.c, yeah, it's actually the same here. So actually we want to look at the parser where it starts to get interesting. So we get the entry point. Yeah, we just check exactly the same as we do with any jumps and such. Yeah, so we just check if it's a label or an int, and then, yeah, and then we do that. So, actually I'm not sure why we do this with dupe, because the label would not be valid. So that is something I need to look at. But then in Tasm.c, we actually set it here. So we just set the instruction type to a nope. So it just skips over it. It's not, yeah. And then here we check if it already has an entry point. So if you try to set it twice, then you'll get an error. Yeah, so I need to actually, I need to add something where it shows where it was set before. I should do that. And then it has an entry point equal to true. And then down here, we actually set the entry point to that. So instead of doing all this, I really should just pass it in here and set at the end of the function, just the machine itself. I'm not doing that right now though. So, and then in the tin.c, we have read, or actually it's write program to find. Basically, after we write all the strings, then we just write here, it's a size t, just the entry point, to the machine. We don't put has entry point because it doesn't matter here. Yeah, and if we don't provide one, it just gets set to 0 automatically. Yeah, so that is sort of how that works. Yeah, so it's still valid to not have an entry point, which I'm thinking about changing that. I'm not sure. And then here, after we read all the strings, then yeah, we just read this to the entry point, and then it sets the entry point, and we just start it on the entry point. So if it's 0, then it starts at 0, obviously, or it starts wherever the label is at. So that is pretty cool. Yeah. So your proper entry point. So we can really use the standard library. We can really start to build it out. And I think I'll probably move all these things into one, just like basically std.attach, I suppose. Something like this. Yeah. Yeah. So if I open up print int here, for example, I can actually bring this all down, all of this, and then place it in here. So we have convert. Yeah. Okay. So I don't know what. Oh yeah, because that is the new line. We don't need that. Yeah. And then okay, and then we also have print float. And then I'll just drag this into there. And there might be some conflicting things with some label names. Maybe not here, but oh yeah, see, something like this. So not neg. And we almost have the same thing here. Because we don't have any sort of scope at all. So if you define a loop label in here, then it would be used out there as well. So I might add a scope, at least very basic thing of it, but for now I think it is fine. So now if we go into print in example, instead of this, we can just include standard.attach, and we have the entry point main, and it should still work. Let's see, so this is example.tasm, okay, example.tim, and it does still work, so that is good. And then we have the print float example. So we need to do the same thing. Same thing here. And there was actually a problem with this, which I did not get to figure out. So example. Okay, print float example dot tim. Yeah, so you can see we print out more than we should be. So that is not good exactly. Yeah, because we're printing out the, yeah. So I think I need to figure that out. So figure out why it's doing that. Because I don't think it was doing it before, but it is here. So let me move this. I'll just put it at the bottom. It doesn't matter, because it's the same no matter what. But I want to figure out what the problem with that is, and then I'll actually try to implement a few more standard library things. Yeah, and if I build it all out in here, try to not use the native functions too much, then that'll be really good for portability. So, we actually use, right here, okay. So let's look at everywhere where we use native 1, which is the right syscall. Okay, so we do it here. That is to print negative, if it's a negative number. And then we also use it here, and this is actually printing the number. So if I get rid of this, then the print float will not really do anything. Whoops. Yeah, so if I recompile this, then, okay. So it still does print out that. So that is interesting. So what is this doing? So that actually is the last one that it prints out. The actual... Okay. That is interesting. What do I need to save here? Third label name. Oh, whoops. Yeah. There we go. Okay. So, yeah. So, let me look. And then down here, all the printing should be done in printin, except for the dot, because we do print the dot, but we don't use it anywhere else. Negative 1, yeah, because that is that, and then we use it there to print the dot, and that is it. So, yeah. So let me, we call print int here. What if I comment that out? That's not tag. No, it is print float example dot tag. Print float example dot tim, and okay, so that does get rid of one of them. One of the extra things. Is the issue that we actually want to we want to call convert rather than print int, because this is just like the intermediary that just completely messed that up. That is what that is essentially, and this is the actual implementation. So yeah, we don't want to get rid of that one. This one though, so why do we do that there? That is if it's negative. I need to implement this again, because I'm not sure why it is broken now, because it was working. Let's see. So where's this first one getting printed at? That is what I would like to know. So how do we get rid of that? Let's see. If we go here, get rid of that, then yeah, okay, so that gets rid of that. Okay. Let's see. Call print in. That is the print in. Yeah. So. Yeah. So I'm not sure why it is calling that. Wait. Let me get rid of any calls to anything. Yeah, so we have that one, and then native 1 as well. I'll just get rid of all of this. And then I will see what it actually does. Ooh. So why does it... How does it still print stuff here? Because it shouldn't be. Because we just got rid of... What's it? Right. Yeah, we don't call that anymore. Native 1. Ooh, we still call it here. But that's just for the dot. So we're not printing anywhere else. So what is the deal with that? Push that. What is native 8? So that is power. Yeah, so that is actually what we just implemented. Let's see, what other natives are we calling? So we have native 8, and that's it. So I'm not sure where the printing is coming from. Unless... So that is all that we print now. We do print a new line here. Let me get rid of that. Okay, so float. No, that is in the wrong one actually. No, it is in the right one. Yeah, but we have this. We shouldn't be calling this anywhere though. So that should be fine. Because this is something separate. Yeah, I don't know why it is still printing stuff. This doesn't quite make sense. Are we calling anything else? We call convert there. Okay, let me get rid of that call. Yeah. So let me remove float example.tin and then recompile it entirely. And then I will run it with this. And okay, so it still prints stuff. So yeah, if I get rid of this call, obviously it won't print anything. Yeah, so it is happening in here. Let me get rid of the comments that I added, and then I'm going to try something. So, yeah, oops, there we go. So if I run this now, then, okay, it prints everything out, except the new line that we commented out. So if I just get rid of this, then it shouldn't print anything except the dot. Okay, and it still does print stuff. Okay. Let's see, let's print. Okay. So that is what's on the top of the stack. Basically we just don't want to print the new line, but where is the new line coming from? When we print 64, why is there a new line? Yeah, here we go. I have no idea what's happening. Okay, yeah, obviously that just returns. Here, it will do the same thing and it shouldn't print anything. And it still prints that. So we are printing that outside of this entirely. So in here, ooh, okay. So this dot doesn't actually work anymore. Yeah, we need to make this a string. And I think I know why. No, okay, maybe not. Why did it underflow? So this is standard out. I think right here. Okay. So that is correct. Yeah, so it's actually not that. Yeah. Let me make a test file quickly. And then I want to tell something. So if I push dot and then push 1 and then -1, will this work? Because it did used to work, but I think, yeah, it doesn't work anymore. I need to reference it next. Ref. There we go. So it does still work. Okay. Oh yeah, because I changed the way the references work, so I thought that might have broke stuff, but that is not what it is. Okay, so. So where is this actually being printed? Okay, so it's before there. Okay, okay, so, ooh, did I add a print statement in here? I might have, actually. Is that really what it is, though? So, oh my gosh. Okay, that's what it was the whole time, was it? Yeah, let me get rid of that stuff. And then it should all work now, eh? Okay. Yeah, that is what, oh my gosh. The issue was literally I added a debug print statement and I forgot about it. Okay. Yeah, so we can make this anything now. And it will still print. Yeah, that is, yeah. A little. Okay, and I can make this 3.0. Print out 3.0. Okay, perfect. Yeah. So, I spent all that time because of that. Okay. That is super cool. Super cool. Okay, yeah. Okay. But now we do have that in the standard library. So that is cool. Cool stuff. I can get rid of that. And then these, I can completely get rid of. So let me just remove print float float.hash and print int.hash. Alright, and then I will actually move these into those files. So into print int.casm, move print float example.casm, print float.casm, and then yeah, just remove print int example.tim and print float example.tim. Okay, so yeah, now now it's a bit more clean. Tim, okay. Yeah, we don't print the new line there anymore because I got rid of it. So print int, and let me just uncomment this. And then recompile it, and there we go. Okay, so what else can be moved actually into the standard library? Do we have any, maybe into stir? What? Oh no, that is something different. So stir string reverse and string len. So stir len. Yeah, so we do have this. So it uses the string. I think instead we should get the one from the top of the stack. Just a pointer to it. Or maybe in a register. Okay. Well, actually, that is what it does. So let me just copy this. Right there. And then I'll put it in here at the bottom. And then I will... this can actually be something like that. So get stir 1. So that is what it's trying to get here, I think. I think that is what it is. Yeah. Okay. So yeah, I think I might need to rework this, considering what we have now. So this can just be push a character, because that's all it needs to be. And then essentially, you can just push it here, and then reference it. And let's see, I think that's the only place that we use that. So, then we might want to swap and pop. Let me move this in back into the stir line so I can test it out. Yeah, so, whoops. Right here. Get rid of that. And then I will use a return. Yeah, this is actually pretty old example. So we can actually call rather than using jumps. Call string. And yeah, so get stir 0. So that is what we want. And this can be entry point. Main. There we go. And I will move it down here. We don't need the end. And let me try to compile this. Stir len. Tim. Okay, and it segfaults, so it doesn't work. Okay, so reference swap pop. Ooh. Might not work when we pop off the reference of it actually. So it still segfaults. Yeah, because now we need to, so this is string compare. So this is a native function. So I think I could make my own string compare in the standard library. So that is something that I'll have to do. But let's see. So here we swap. So that puts the string on the top of the stack. The string that we have here. Yeah, so that is what should be on top of the stack after we swap. And it still segfaults. Yeah. Okay, so that looks like that's what it is. And then we duplicate the string. And we push this. And then a reference to it. Okay. Yeah, so that actually fails when we get rid of the reference to it. So, what if we push that? Hey there, Bob Ross RTX. How are you doing? Alright, if we push it there, and then reference it, and then we move R0 top, and then pop, and then move R1 top, and then it's stored in the register. Okay, yeah, and then pop it off again. So then instead of this, we will just basically push R0, because that stores the reference of it. So then we don't need to do all this. Okay, and then we get 236. So that's not right, obviously. Annoyed at Deno, or is it pronounced Dino or Deno? I'm not sure. Yes. Sorry about that. Hey there, Tanish Solanki. How are you doing? Okay. Yeah, so that is not right. Not the right amount. But we are closer. So yeah, we're performing a string compare. On that. So we're checking that. Yeah, so it is closer now. I don't want to swap here actually. No, I think I do. Okay. Has the urge to be a pain in the ass when I want to set a custom icon to my executable. It does, really. And it doesn't have good support for that? That seems like a bit of an oversight. Yeah. Okay, sorry about that. Okay, so yeah, we have one there, obviously. Okay. So yeah, so this actually uses print to see that. Do I want to, let me print again. That should be the only thing on the stack. It is not. So, yeah, because that looks like it's the pointer actually. So if I push 1, and then native 1, then it should print out the string. Ooh, I think it's the end of the string, so that's why it doesn't print it out properly. Yeah. Okay. Let's see, is there anything under that? There should not be. Alright, there's not. So I can pop that off, because I don't want to leave that on the stack. And then, yeah, so it does fill in the registers, but that's okay. So, we're string compare. The string compare might not be working. That could be the issue. Okay. Let's see. Yeah, so it is that regardless. If I do something like that. Alright, what if I make it a character? So like T, or okay, 5. No, T is what I want. Then alright, so it's still the same. So it is not working. Alright, let me make this a string now. Push stir. And then we'll get stir 1. And then we'll move that onto the top of the stack. And we don't need that again. Okay, and then it gets the correct length. So yeah, it doesn't work with the character like that. And I don't like that. So the problem, well, I guess we could pop that off the string stack. But we don't, yeah, so I think then we should do stir swap with 0. Yeah, it's hard to work with it like this. Alright, well, at the end, let me pop stir, because I don't want to leave it on the stack. Okay. Well, so that works now. Let me take this, and then put it in here. And actually, this will actually be string 0, at this point. Because, yeah, okay. Yeah, so it is string 0 because we don't have any other strings up here. And it's top down. So, yeah. So that is what that is going to be. What is this? Oh, that's the old one that I was looking at. Okay, I can get rid of that. So we can do that, and then it should all be fine, and the stack should be clean. I don't want to use print either. So if I get rid of this, and then, yo, Schooly B, how are you doing, man? What's up? Alright, yeah, so let me import standard.cache. And then this should all still work. And it does not. Okay. Because this needs to be string 1 now. Yeah, okay. So, yeah, that is not ideal. But that's how it's gonna work. Okay. I guess that is okay for now. And we can call the string length now. So, and instead of printing it, let's actually do print int. There we go. And then we do, we need a pop. So, yeah, we need to actually call print int. And then run this, and it prints 26. So then we have to print a new line as well. So push new line, and then reference, and then push 1, and then I'm doing alright. Finally got the basic inventory system for my text game done, so taking a break from C to make a website for the game. Alright, that is cool to hear. I'm glad you got that done. That is very cool. Very cool. Yeah, negative 1. But now, ooh. Non-type but found a label. Is it this? Okay, I think. Yeah, okay, that is what the issue is. So we can't just compile print int. Yeah, in here I don't want to use it. So let me get rid of strcomp and then replace it with the standard defs. What is that? So strcomp is 90. So this will be native 90. So what are Schooly, what are you using to make the website? Like, are you using a framework, or is it just vanilla JavaScript, or like what are you doing exactly? I would like to know. Yeah, so that works now. That's the print in actually. I want to look at this one. No. I want to look at this one. There we go. And that works. So it prints it with a new line. So that is cool. So that works now. We don't actually want to print it every time though, do we? We actually want to just leave it on top of the stack. So, yeah. Okay, so what I can do, I suppose, is rather than doing this, so we have it on the top right here, but we have other stuff that we can call out. So we can swap and then pop, and then it should be fine. And now it's not going to print it at all. So we can just print right here after we call it. We can see what it says. 26, and then there shouldn't be anything else. Okay, perfect. So that is what I wanted. But if I push other stuff here, push 5 and then push 6, then it should be on the bottom of the stack afterward. And, okay. So there's actually, oh yeah, because we're swapping 0 there, and then it, okay. So yeah, there's some problems in here that need to get figured out. So I think we might be able to solve it actually using registers. Because that might be a good idea. Static HTML, CSS, and JavaScript, but I decided to use SvelteKit, TypeScript, and Tailwind CSS. Okay, I've never used actually any of those. Yeah, I've only used vanilla JavaScript, so no TypeScript. I've never used Svelte, or Tailwind, so that is pretty cool. Yeah. And I don't really care to learn it, because I'm not a big fan of web development. Yeah. Maybe Tailwind, though. That does sound kind of interesting. Yeah. So, let's see. So this, I think it has to do with these in next swap 0. So I might need to just rework this entirely. It's not too big though, so it shouldn't be too hard. But I feel like that's going to be a good idea. Yeah, so what if we move our 0 top and then we pop it up? So that is essentially what we do. So we prepare the register. And yeah, so if we use R0, then this could be R1 instead. Which maybe we don't even want to, maybe we just want to get story 0 here and not use the register at all. Then we can just use R0. Yeah, then we don't need to do that. Alright, and let's see. Let me compile. After using React, SvelteKit is awesome. TypeScript is just JavaScript, but more time for the programmer. Yeah. SvelteKit. I have not looked into it at all. I've heard of it. And if it's better than React, then that's cool. Because I used to use React, and not a big fan. Okay, web development streamline. Just want to read about it a little. Okay, do they have just like about? Okay. Web development street. Alright, documentation. Let's see. I want to look at what it looks like. Kind of sidetracking right now, but that's okay. Where's the deployment? Yeah, let's see. SvelteKit. Okay. Svelte renders UI components. Okay, so that's for the entire app. Okay. Creating a project. Do they have some examples? Web standards. Okay. Does this show? Okay. So. Okay. Okay. I have most experience in front-end web dev, but I would love to get into working more low level. So you work professionally with front-end web development, right? Is that, if that is correct? Chasm, Sterling. Okay, ooh. Oh yeah, because I actually changed stuff around. So we don't want to pop this anymore. We don't want to swap either. And then stuff stops working because we don't have that. Correct. Alright. Cool beans. Something that I've been wondering, I haven't looked into too much, but like C, jobs using just C, because I have not gotten a job as a developer yet. Like what jobs are there for C developers is what I'm kind of wondering. Because like I know there's like embedded systems that uses a lot of C and such, but most things use like C++, right? Like the lower level stuff, like application development and things like that. Like where else do they use C mostly? Okay, push 0. So what is that for? And then actually, yeah, we can just move that to the top. So push R0 like that. It's still segfault. So we gotta swap it again. Okay, and then now it works. Now we just need to clean up this. Is that better than using the stack though? I don't know. Yeah, so the problem is when we inswap 0, so what is the goal of that we're doing here? So if I look at this, so we push that and then we swap it. So on top is the pointer, and then we duplicate the pointer, and then we get this, and we compare it. That is string compare. So right now, we have, on the stack, we have 0 and R0, which is the stir. And then we also have stir 2, which is this one. Interesting question. In my company, I am unsure, but I can look around. Okay, yeah. Well, so I know that, like, a lot of software is written in C, but a lot of it is open source as well. So, and, like, not necessarily, I'm not sure that there's that many jobs in that. Yeah, I'm not sure. I don't know. I don't know. Okay, so, swap here. Yeah, so we're here now. So do string compare. Does that actually consume it? Ooh. It's actually native stir font right here. Native. Wait a second. Go back. Why do I have 2 of these? I don't need that. Okay. Yeah. So we do pop it. Okay. And then we push the result. So that will actually remove these 2. So yeah, that's why we actually have the duplicate of that. And then it removes these 2. So now we are left with 0 and string. So then we swap it. So we have stir and then 0. And then push 1. Alright, and then we add it. So this becomes 1. Okay. And then we index swap. So we just want to swap rather than index swap. And I think that should still work. And then we 0 jump to loop. And this, I'm actually going to change it to stir len loop. So that there's no conflicts. Stir len loop. And actually I will do something like that. Yeah. Okay, and then can this just be swapped again? Let me just try that. Okay, it doesn't work when we do that. I'm pretty sure this one still works at this point though. So we should be good on that. Actually, why do we swap it here? Yeah, why is it swapped there? If it's 0. But we're adding to it. So why would it become 0? I'm not sure where the 0 comes from. Okay. And then we go down here and we swap it again. So then we have 1 on top, like that. Or not 1 on top, rather, the string on top. Okay. And then push 1 and sub. And then sub. Okay. Actually, let me. I think that's not right because we swap it here. Yeah, and then we swap it back, and so it is 1 on top. That is actually correct. And then we push 1 and sub, so this becomes 0. And then swap it. And then pop that one off and pop the string and return. Okay, so okay. I think I'm gonna start over. To this point. Okay. So this is where we're comparing to see if it's equal to 0. So yeah. So string compare. So that will actually push the result on the top. Yeah, so it pushes this result. So I didn't actually consider that with the last iteration. But yeah, so it'll push the result. So it'll be 0 initially, and then once it's 1, let's see, let's do push 1 and then compare equal. Actually, we can just do not 0 jump to stir len n, like that, and then we can make a stir len n, which can actually go here, in return or whatever. And we will implement that momentarily. Let's see. So, yeah, we don't need to use compare at all, actually. So, what is this push one? That? Okay, so that is where we're comparing it. And now we need to actually iterate the string. So, if it is not that, then what are we at? On the top. So, let me look. So we push that, and we push 0, and then we swap them. So it's 0, and then that. And then we go here, and we duplicate the string. And then the other one, and we compare them, so we're like that. So we do want to swap. We want to iterate this, and then we want to iterate that. So, we push 1. Actually, we can push 1 and then add. and then swap, and then push 1 and add again. So that will iterate the string and the counter. And then I think we can just jump to Sterling loop, like that. Okay. So let me print, what happens at the end? Okay, so it didn't reach the end, so I'm assuming it just looped a bunch of times. Okay. So. Check out your Pong game video on YouTube. Still amazed that you work on so much. That one, yeah, the Pong one, I need to get back to working on that, actually. Because I've been taking a break and just focusing on this. Yeah. I don't know why, but I just, I work better when I have a few different things going on, basically. Like, if I have one project here, then another project here, and I can go back and forth, yeah, I'm just better. Because, like, then I can take a break from the one and move to the other one, and, yeah, just work better. Like that. Not sure why, though. So, yeah. Okay. So let me see where we are at. Okay, so let's print what this is. So it's 0 and then 0. Okay. Do we not iterate this properly? Print what is here. So that should be 1. No. Ooh, okay. Oh yeah, because that should be, if I push 1 and then native 1, some people would kill to have that skill. Oh, that didn't work. Huh. Well, it's not necessarily a good skill, like when I get a job at working on a thing and I have to focus on that one thing, I can usually only hyper focus on one project. Yeah. Well, yeah, but if I had to focus on the one thing, then my progress may diminish. Yeah. Okay, so what is the issue here? So we push that, and then push 0, and then we swap them. We duplicate that, and then we get that, and we compare them, and then we have 0 on the top, and that consumes 0. Then we have the 1. So can we not add to that? Oh, yeah, true. Yeah. It's good for like this, like streaming and stuff, because then I can jump back and forth, but yeah. Okay, so this doesn't work when we do that. Okay, so what if we print, or what if we native 1 before adding? It still breaks. Is there no null termination character on it? Let me push 1 and then native 1. Alright, so it breaks there too. What if I do this? Native 1. Okay, so that does work. But then, okay, when we move it there, it doesn't work anymore. So we might need to utilize the stack rather than doing this. But that's okay, I think. Ooh, you know, it's because we pop an arc, isn't it? That might be it. Okay, yeah, let me just use the stack rather than this. Then we have it on the stack, so actually, I don't think it changed that much. So if I push 1 and then native 1, we should still have it. Okay, no, it still breaks. So, okay. So why doesn't that want to work? Native 1. So we shouldn't have anything else on the stack here. I'll print this. Then, okay, yeah, stack underflow if I do that. So for some reason, it doesn't want to print it. But we can here. Let me do and then print. And then print here. And are they the same? Yes. Okay. But why does it not print? Why does it not write properly? Yeah, I don't know. Alright, well, let's see if we can do this. And maybe it will work. Okay, so we push it, and then it's the same deal, and then duplicate it, and get string 0, string compare, so that should be 0. Yep, so 0, 0. And then if it's not 0, then we jump to the end. Otherwise, we push 1 and add, push 1. And let's not do that. Push 1 and add, and let's print that. And that should be... So, we need to actually swap here. Oh, okay, actually, this is the issue. We need to not do that. There we go. So if we do it like that, and then we print, and that should be 1. Okay, so that's 1. And then we jump here to the loop. Ooh, but we need to swap it back. So, yeah. So swap it again. Okay, 26. There we go. So, yeah, when we print it at the end, let's see, where else are we printing? Is it... Oh, it's in here, so that's where we print that. So we can pop that off, because we have the string there, and we want to pop it. And there we go. So now we have 26, and that should be all that is on the stack. Okay, and then if we push a bunch of random stuff here, and then I try to print it all, those should be on the stack as well. 23, and okay, perfect. So there we go. Now it works, and it returns it. It's on the stack. That is exactly what I want. So now we have stringlen, which we had before, but it wasn't exactly right. Yeah, and we can print it out, or we can do print int, and then print int. Oh, there we go. And it prints 26. Okay, and we can push a new line, reference, push 1, and then right, you print it out like that. There we go, and we can print a new line, and there we go. So that is the length of this string, and if I change it to anything, hello world, and it will print the length, 14, perfect. Yeah, so that is pretty cool. Now, string compare, because we actually use that in here as a native function, and I would like it to not be a native function. So basically, takes the two strings that are on the stack. So I can add it up here actually. Stir compare. Yeah, it takes the two strings that are on the stack, and then it compares them essentially. So it goes through. Yeah, okay. So how are we going to do that? So let me implement it in. So we can save this one. I will push that there and just return it right now because we're not going to use that yet. So I need to touch string compare dot chasm. There we go, and then I'll open it up and just put that in there. And then I'll add entry point main, and we'll have a main here. So basically, what I need to do is compare. So if we have two strings, so if I just push stir 1, 2, 3, and then get stir 0 and duplicate it, so they will be the same, and then we call string compare, and it should put 1 onto the stack. Okay, and now it works. Yeah, so that works. If we compile it, there we go. Yeah, so it works. That's what I wanted to do. Let's just if they are not the same, so we push stir 2, 3, 4, and get stir 1 like that, and don't duplicate it, then it doesn't work. Yeah, because obviously you just push 1, so that was just kind of a joke. But I can make it work. So if we go through and compare them, so basically we need to dereference each character. I think we can do that. Let me see. Deref, and then print, and that should print it as a character. Let's see. Do you have any books you like to read about C? I have the C Programming Lang book. I have not read that book. Let's see. Most of the books that I've been reading are specifically about like compiler design and such, programming language design. So there's crafting interpreters. Yeah, so like this one. This is a good book. I haven't finished it yet, but it has some good stuff in there. Well, so they build, first of all, they use Java, and they build, it's an interpreter, an interpreted language, and then using C, they rebuild the language, but it compiles to a bytecode and works on a virtual machine, like what I'm doing here. So there's some good stuff in there. Yeah, so that is one. I can link to that in the chat. Very good book. And you can actually read it for free on the web, and that's pretty cool. Or you could buy it. Yeah, so you can see here, tree walk interpreter. So that is they build the syntax tree, and then yeah, it just goes through the tree and interprets it. And then yeah, bytecode virtual machine. So that's like what I am doing here. Yeah, so that is pretty cool. Took a look at that one before. Was on the JLox portion. Yes. Let's see, which one is that? I think, is that the interpreter or the bytecode interpreter? Yeah, I haven't really read a lot of books on this, so this is, I also started reading the Dragon book. Yeah, but I've heard it's kind of outdated in some ways. So maybe it's not the best. Yeah, compilers, principles, techniques, and tools. I like there was the first published in 1986, and then I think 2006 there was like a refresh. My internet's dying. Yeah, well, so this one, if it loads, you can see that's why it's called the Dragon book, because that was the cover. Yeah, but it has, so you can see here. Yeah, I've heard that it has some problems on it, outdated and stuff like that. So that might not necessarily be the best one, but those are the only ones that I've really started reading through, for C at least. Yeah. So I don't really have any other ones to recommend. Okay, so what did this print out to? Okay, so that's actually, let me make it like this. Yeah, so then we can look as a character, and that does work. So we can dereference it. So that is what we will need to do. We can dereference it and then compare them. Yeah, so that is basically what I need to do here. So I don't need to print that now. Okay, so we have the strings. They're on the stack. Both the strings are on the stack. And then, basically, let's see, if we deref, and then, deref, and then we want to swap them, how could we do that? So maybe I need to use registers. So what if I move it into a register? So we move R0 up, and then do the same thing into R1, and then we get it out of there. Could that work? Perhaps that is a good idea. And then I can just, rather than it being on the stack, so then we can actually just pop it off. There we go. So now there's nothing on the stack, but it's in the register. So we can push R0, deref, and then swap and pop, and then we can push, let's see, push R1, deref, and then swap and pop, and now we have the two characters on there, so we can compare equal. Well, actually there should be, so let me print them to make sure. And okay, so 1 and A. Alright, so that is perfect, that is what we want. So we compare equal. Yeah, so if they are, basically, we want to do 0 jump. So that is if they are not equal, then we want to do stir comp loop, like that. And I will define that up here, so stir comp loop, like that. Then I can actually indent this, so it is a bit clear. Something else we need to do, though, is actually iterate. So when we swap here, let's actually push 1, and add, and then pop. Let's see, will that modify it? Let me try that. So, push 1, add. Alright, let me try that. Alright, stack overflow, so that didn't, so I think we need to then update the register. So then push R0 top. And then, yeah, push R0 top, like that. And that should pop it off. So, okay, and ooh, that is interesting. So, an assertion failed. Did I do something wrong? Did I use the wrong keyword? I need better error handling, because that's not a very good error message, because I have no idea what's happening. So, so it's something that I just did. Is it these? Okay, so it is those. It doesn't like them. Why? Yeah, okay. So let me actually open it up. TASM.c. That is actually back here. So open TASM.c. And then let me go to the assert. So let's see. This is the assert that fails. And then in pretty token. Can we do that actually? Pretty token. Head value dot. Let's see. Does that work? Oh yeah. So okay. Okay. So why is this token is not any? Okay. So it doesn't like that. Yeah. So that is what. Oh, you know, I messed this up because I edited the wrong place. So this is what I wanted to get rid of. So let me build that now. All right. So now let me try doing this again. And then I didn't rebuild it, I think. No, I did. So why did it not do that? Because that should be putting it out. I thought that it would. Okay, I guess it won't print it out. So correct value. Right, can I provide, I don't remember if you provide printf things like this. Free token. Yeah, okay, I think that doesn't work. Assert is now undeclared. What? Yeah, okay, it's actually the issue with that. So that is not what I want. That doesn't work. I didn't think it would. Okay, so build that. Incorrect value. So what is the actual value? So let me just print f. Pretty token. And then I just want to head value. Okay, and if I build that and then I try to run this, it is on top. Okay. Okay. That is the issue. So I need to move, not push. Yeah. Okay, that is something. Okay. Yeah, that's what the issue was. That's kind of funny, but okay, let me rebuild this and then yeah. Okay. Now it should work. Okay, perfect. String compare.tim. Okay, so we do get to the end. So let me print what is here. So maybe I need to actually 0 is on top. So what is the 0 from? Okay, so what if I print group and print this, and then we do get to 1 eventually. So actually we also need to check if we're at the end of the string. Yeah, because if they're not the same, but here, let's make it the same. Let's see. So basically, yeah, maybe this should be not 0 jump. And we want to actually jump to the end like that, and then I'll just make an end here, a label like that, and then otherwise we'll jump to circum loop, except in here we want to compare the string to be a null terminated character. So if we push that up here, push stir something like that, and then we can get the string. So this actually needs to all be iterated now. So then if we get stir 0 like that, and then we can then we need to compare then. So we don't actually need to use string compare, right? Because we can just we can actually do the same thing that we're doing here. So then deref, and then deref, and then we also want to get the strings that we have here. So just get one of them. We can just push R0, deref, and then swap and pop, and then we'll push R0. Yeah, so then we can deref, and then swap and pop, and then we can compare equal. And then, yeah, so then what we'll do is if they are equal, then we will, so not 0 jump, 0 jump, in. So basically we have 2 checks for that. Otherwise, we'll just go there. So let's see what that is. 0. So 0 is what we print right here. Okay, so why does it let us print more than once? Because we actually skipped right past this, right? Yeah. Because none of this is in the end, actually. So let's print there. Alright, so we have a bunch of zeros. How many zeros? Then we have 51. So I don't know what that is from, actually. Ooh, that is actually the characters. Okay, the last characters. Alright. So we will need to pop those off. So let's just see what else we have on here. Okay, so then we have a duplicate of the character. So all these things need to be popped off. But actually, let me make the string the same really quick and see if something changes to be 1. No. Okay, so then... Alright, actually, the way I'm doing this is not right. Because we're comparing if they're equal. And just if one character is equal, then we jump to the end. That's not what we want, actually. Ooh. That makes it a bit more complicated. So... well, something I can do, actually. So, what I was doing in here is we were getting this string and then comparing it. But instead, we could just dereference it and then swap and pop. And then we could do compare equal. Yeah. Instead of doing this, I think that'll work, actually. So if I build this now, or, if I, now if I do the stir len, I'm still going to implement this, but we might be able to do it without that, and that would make some things a bit more useful. So we got Tim, and, okay, no, so it doesn't work then. So we stack overflow. Let me print what is on the top. 0, 0, okay, so we get 0 a bunch of times. So, do we need to dereference this? So that is actually this here. And we swap them and we pop them, so we should be fine with that. Ooh, but compare doesn't actually get rid of them, does it? Actually I want to print and then pop and something like that. Okay, 23, so that is not quite right. I just want to pop once. Oh, well then we don't need to duplicate it here, because compare doesn't consume them. It just looks at them and then pushes the correct thing on the top of the stack. So keeping that in mind, whereas string compare does consume them. So if we do this, and then, so we have the string on the top, and then we get this one, dereference it, swap and pop, and then, okay, so then we have the character there. We do have to dereference the, dereference that as well. And then swap and pop. No, because we don't want to swap and pop. So, ooh, that makes it a bit more complicated. Ooh, okay, okay. Yeah, because then that does weird stuff. So, yeah, because then we're dereferencing this and comparing the character, because that's what we want to really do, is compare the character with the other character. But to do that, we need... So I could move it into a register. Yeah, so then I don't need to use a string for this, actually. So if I do that, and then don't push a string there, and don't do this, and instead we just push the character, and then we don't have to dereference it. We don't have to pop it off like that. So we have the character on the stack. That is really what we need. Then we swap it, so we have the string on the top. Dereference it, so we get the character. And then compare them. So we do need to... essentially swap it a few times. So what if we... what if I push that, and then basically move R0 top, and then pop it off. So then we don't have it on the top. And then we can dereference that. So then we have that. And then we can push R0 and then compare them. And then we have to pop them both off. But first print what this is. There we go. Okay. So that's almost right. 23. It's still not what I want though. So, because we... Oh yeah, because we don't actually do that. So, then it's say false. Because we still need to pop them all off. But first, first we need to do this. Then we can pop it off. Yeah. Or we could just do swap and pop. And then swap and pop again. And then we don't have to worry about that. Okay, 14. There we go. So now it is right. We don't use the string, so that is better. And we don't use this native function. So I will continue implementing the string compare. But now we have that in mind. So let's see where we were at with this. So here is the loop. Okay, so let me run this. So that is what we got. If they're the same, yeah, so we need to change that. So, what is the way we can do that? So if we look at, we have to look at each character and they have to all be the same. So what we can do is we can have a value on the stack. And basically, we iterate it if it's ever not the same. Then once we reach the end, we look at that value, and if it is, maybe it could start at 1. And if they're ever different, then we set it to 0. Then at the end of the strings, we just return that value. So if it's 0, then that means, they were not the same, and if it's 1, then they are the same. So let's do that. So let me start over, actually. I think I'm gonna need to do that. So, yeah, and we don't need this either. So let's see, we will need that like that though, and I will actually move it into a register. So I'll just do R10, I suppose, top, and then pop it on. So now we have that in the register to get it. I guess we don't even need to do that because we can just push like that. So we don't even need that. Yeah. Okay. So let's do what I was just saying. So we have both of those, but they're in registers. Okay, so we have R0 and R1. That is where they're at. So let me just push R0, push R1, actually deref, and then pop. We'll actually go iterate it, and then we'll move it into R0 again, and then we'll pop it off. There you go. Yeah, so that will move it past 1, and we'll do the same thing with this actually. So if I grab that, same thing there. So then it will iterate them, and we'll also get the characters. So we should have just the characters on the top of the stack. String stack out. Oh, okay, because this doesn't need to be that. There we go. Okay, so so we only have those. So I did something wrong. So we push that and then dereference it, and then because we didn't swap it. That is something that we need to do. There we go. So we're doing. There we go. So A and A. So that is good. So then actually to start, we want to push 1. So yeah, and then we'll set it to 0 if they are ever different. So basically, we'll compare equal. And then if they are not equal, so 0 jump, to end, stir const end, like that, and I will actually make a label for that. Stir const end, like that. Yeah, so we'll do that if they are not equal, because then we know that they're not. So we can pop them both off and then push one and add like that, and that should return that if they are different. That is just on the first character though. So I think it's B. No. Okay. There we go. And so it returns 2. So that is not. Oh yeah. So actually, I want to push one and then sub rather than add. There we go. So if they are not equal. Okay. So 0. But then it shouldn't return that. And it returns 0 anyway. So oh yeah, because we do that. Actually, let's make a not equal rather than end. So basically a not equal. And I need to add this because there's no scope. And this will actually not equal rather than the end. So let me actually swap and pop, and then swap and pop. There we go. And now that should yeah, and then it gets messed up. But that's because we go through here. So yeah, we can get rid of this and that as well. So that is if they are not equal. If they are equal though, otherwise we can jump to stir const loop, and then I will define that. So it'll be right here, stir const loop, like that. And I'll indent all this actually. Whoops. There we go. Okay. So 0 jump to there. Otherwise we jump there. Okay, so this actually needs to go above it. I think. I think that would be. Maybe I'll just make a different label for that. Something like that. And then this can return. So yeah, we'll call that rather than. Well, actually, it wants to jump there. So yeah, then we can just jump to the end. And, yeah, and I will make a label for that. And so yeah. But then if we get to the end, we also need to compare them with the null termination value. So after this, we'll compare it. So we'll push that. So yeah, we'll push that, and then we actually want to get the values stored in the register. So we can push R0, then deref, and then swap and yeah, like that, because we don't need it there anymore. So then we have the character of it, and then we can compare equal, and then yeah, so then we can jump to the end. So for this, if they are equal, then we don't want to do this. So we can do 0 jump that, otherwise it will go to the end. Okay, so let me try to do that. Okay, so we got this. So that is not right at all. So I don't know why that happened. So I'm assuming it's just calling this a bunch of times. Do, and then, so let's see. No, so it only calls that once. Where else do we add? Because that's just this, right? Oh, well, let's print this. Okay. So I don't think these are being called. So, but we do need to swap and pop here. There we go. Okay, 0. But that's not right, because they are the same. So we don't want it to be 0. So it is being called when it shouldn't be. Okay, so that's not good. Let's print whatever this is. And it is 1. Okay. 1, 1, 1. That means they're the same. So if they are the same. Okay. So if they're the same, then we don't do this, but then we push that. We push that, dereference it. Let's print the dereference value. Okay, so B. Okay. B. Okay, and then we swap it. So we pop this off. Then we compare equal. We'll print that. And it's 0. Okay. That is what we want. Swap, pop, swap, and pop. And then if it's 0, we want to jump to the loop. So I don't know what the issue is exactly. So is that is right there. That is what's being called, right? Yeah, so for some reason, yeah, for some reason, we're never going here. So do we not just drop in? Let me take this actually and embed it in here. So I can put it right. Let me see. Actually. Actually. Okay, so we have all of this. So we don't need to do that then. But we do want to skip past this. If we are here. If they're equal, then we want to jump to the end. So if I just duplicate this, 0 jump, and then not 0 jump to start count end, like that. Okay, and then we don't print anything. So we still don't get here. So I don't know why we don't. Are we still here though? Okay, so we still go here. So 0 is on the stack here. So why is there 0? Let's print that. So we have 1. So we don't call that. But then we go here. And then print that. And that should be 0. So we jump up to the loop. Dupe and print. Let's do that. Okay, 1 and 0. So what is that from? Okay. Okay. Okay, I think I'm going to take a quick break. So I can actually show off this thing that I made. Quick break. And I'll just say about 3 minutes. And there we go. Okay. Yes. There we go. I will be right back. Okay, I am back. I do apologize for that. And I'm actually early, so that is cool. Yeah, let me close that. Okay. So, let's see. So now I am ready to do this. So, let's see. So right now, 1 and then 0. So what is that we are printing actually? is. Okay. I think my internet is dying. Okay. So where are we printing that from? Let me search for print. At the end there. So that's what we're printing. Okay. No. So we aren't printing that. Okay. So I'll get rid of that. So we never actually get to string compare A. This, yeah, we don't want to return. We don't want to return there. Actually, we want to, yeah, we just want to continue. Yeah, okay, and then print like that. Okay, so -1 and 1. So that means they're the same, right? So what's the -1 from? I don't know. Ooh. Alright, so if we make them different, like that, ABB, then, alright, 0. Okay. But for some reason, I guess, when we call this, okay, yeah, let me make it the same actually. Alright, when we call that, we get an extra thing, so a -1. So that is when they are equal. The end. So where is that coming from actually? Is it here? Let me print that. Let me do print that actually. Okay, so we have 0. So it's not in that. See, so that is the right value. Right there. Because so that means it's right. Are we calling this twice actually? No, but oh, okay, so that actually is -1. So we might be. Yes, that brings out -1. That is not what we want. So when we jump to not equal, do we need to pop something else off? Okay, no. Then we break that. Let me swap and then print and see what it says. So we have a 0. That's what I would expect. I really need an operation that is like print stack. An instruction. Maybe I should do that. Well, I think I can just go to print inst print like this, and then I can make it just print the stack. Stack. And then break. Then I'll rebuild it. There we go. Rebuild it. And then it will just print the stack when we call print. So here's the stack. That's what we're looking at. So we have 2 things in there. So where is that at actually? Not up there. So it's right here. We have -1 and 1. So if I do that, then we have 0 and 0. Okay. Alright, and if I print here, then, okay, we just have 1 on the stack. So, oh. And then we have nothing on the stack. Oh, okay. So that's not good. Let's print here. Print the output. We have 1 when they're equal. That is good. That's what we want. But then we have nothing when they're not equal. So that is not good. So for some reason this gets popped off. The 1 here. Okay, sub. But you know what? We actually call this when they are equal for some reason. Okay, if I run this, yeah, okay, let me get rid of this thing. Let me actually change that back, so it doesn't print a stack. So that actually is making it a bit more confusing. Alright, rebuild it. Okay, so, we have 0 in there. That is what we want, actually. but then it goes away here. Then we return. Okay. Oh man, I am stupid. Okay. Yeah. In here, I had to print the stack, but it pops the top thing off. So that is why it was doing that. Okay. Yeah. There we go. So we can print here. But it does still print -1 when we make it like that. So there still is the -1. So that is an issue. I really need to make a debugger for this, so I can actually go through step by step on what's happening. But I don't have that. So, alright, we can use this. So, we have the 1. And then we have the string, stir1. If we dereference, so then we just get the character of it. Like that. So it can be whatever. And then we swap them. And then swap like that. And then we push 1 and add, so it's stir1 plus 1, which is just an iteration on it, so it's not really plus 1, but anyways. And then we move it to the top, so we move it into the register and we pop it off. And then we do the same thing. Alright, so we have stir2, dereference it, like that. And then we swap them, like that, and then we have that on top, and we push 1 and we add. 2 plus 1, and then move it into, we move it into the wrong register. Okay. Now we have 0 though. And it shouldn't be 0. So 0, 0. So we have more than 1, 0. And then we have the 1. And that is it. Okay. And let's make them different. And what do we have? And we just have 0. So, okay, so we get extra stuff when they're the same. So we need to actually clean up the stack then. So we are not cleaning it up properly. So, yeah, so we go through here. And then we got to that point. And we compare them. And then this will pop off the characters, these two operations. Then if it is 0, then we jump to not equal right here. But if they're the same, we just continue here and we push this, and then we push that and we dereference and we swap. Okay, and then pop that off. So we have the character of R0, and then also that on the stack. Then we compare them. So that goes on the top of the stack. So we have the character, and then we have that, and then we also have if they're equal or not. So we swap and then pop. So we pop this one off. And then we do the same thing with this. And then we duplicate this. We have 2 of them. And then this should consume both of them. Ooh. It doesn't though. Because if we do this, if this one is true, okay. Yeah, if that one's true, then it causes problems. Okay, I see. So yeah, we can't just do that. So we can't duplicate it and do this. But we can move this somewhere else. Yeah, that's not great. So yeah, I'll move it back up here. And then we'll just jump to stir pump N. Is that not a thing? Oh, we need that there. Yeah. Okay. So then we have that. So we can call that. And then otherwise we just go to the end. Alright, so let me try this now. And then we just have 1. Okay. And then if we make it like that, then we have 0. Alright, perfect. So I think that is what we wanted. So 0 and 1. Alright, 0. However, I think this will still be true. Okay, so it's still not. But then if we make it like that, 1. Okay, perfect. So, yeah, that is actually, and that's good. Yeah. So it does that. Let me try pushing some other stuff onto the stack. And then that should still be there at the end. In that same order. Alright, let me make a different value so it's a little more clear. Alright, so 1, 6, and 4. And then if they are not equal, then 0. Alright, perfect. So it's actually working. That's pretty cool. So, yeah, so we can actually move this into here now. Yeah. Yeah, get rid of this. And then, get rid of that as well. And I should be able to, in here, just import this, rather than actually defining it in here. So if I import, std.tag, then, okay. Something did not work. Unexpected token. So it says in here, that is just I need to fix my preprocessor and the error handling doesn't actually work. But what is the unexpected token? Did I mess something up here? Yeah, so it says unexpected token. I'm assuming it is something in here though. So do I use, string compare? I don't know what that is about. Jump string compare in turn patch. Okay, so it doesn't like this. And it doesn't like that either. Yeah, why doesn't it like that? Because we can do that in here just fine. And it's the same thing. Huh. Wait, there's Sterling baptizing. Right, that still works. That is weird. Okay. So it doesn't want me to do this. That's that. No, that's not. Okay. I guess now it worked. 0, okay. I think that was an issue with my preprocessor, probably. I need to look at that. I should add that to the to-do. Yeah, okay, I want to, there's quite a few bugs, so fix preprocessor bugs. That is something I need to do. These are sort of things I'm going to do off stream, though. Okay, so now we can do this, and it works. I can, yeah. Should moving, no, it should. I don't think so. Alright, I was gonna say, yeah. Let me print here and get rid of that. Yeah, so that all works now. We can call a string compare. Okay. We can also, I guess that won't work. We should add some consistency though, because, yeah, we don't actually use the stack for this one. We use the registers, and then other things we use the stack. So I need to add, I think I'm gonna make it registers, like more consistent like that. So I will do that. But this does work. So these are sort of like data sections, so I can put it like that. Yeah, I can add this as an example now. So 0 and 1, and then you move it into the registers, and then you call it, and then print the output. Yeah, there is nothing else left over on the stack. Perfect. Okay, so let me commit this. Git commit. Let's see. So I implemented better versions of Sterling and stir-compare in let's see, in Kazaa. There we go. So I will push that. Whenever it wants to load. So taking a while. Is my internet dead? Okay, there we go. Yeah, still okay. Almost there. And let's reload this. 6 hours later. Okay. Okay. All right. So it did work. Now, what other ones do we have? So we have. So I want to try to implement some more of these, because we did string compare, and we did stir len. I could do one of these. We also have done these two. Well, printing it, not actually converting it to a string. But I think that's okay. Power. We could actually implement power. Yeah, that'd be pretty easy to do, I think. Let me do that. Power.tasm. So I'll implement it in here. So yeah, power, and then I will move it to the standard library. Entry point name. Alright, so I'll push 1. Or yeah, I'll push 10 and push 2. So I'll actually move it into the register. So move R0, then move R1, 2. Okay, so I'll do that, and then I will call power. Okay, so what we need to do is iterate over it. So while the second argument does not equal 0, so we can actually push R1 and then compare equal to 0. So we need to push 0 and compare equal. If they are equal, we want to jump to the end. So not 0 jump to power n, and I'll get that right here. Power n, and yeah, we can return there. Okay. We will need to clean some stuff off on the stack, like pop some items off, but for now, let's do this. So if they are not equal, we can just continue here. So basically, we need to multiply so push R0, and then multiply it by itself. So dupe, and then mul. Actually, just mul, because it'll be integer. Integer based. Okay. So multiply it, and then, yeah, so we'll have it on the top of the stack at the end of the iteration. So we can do that, and then we can jump to power loop. And it needs an underscore, there we go. Power loop, like that, and this needs an underscore as well. There we go. Okay, so here we can actually swap and pop, and then swap and pop, like that. And now let me try this. So I don't think that's all, but okay, stack overflow. All right, so it gets stuck in a loop. Swap and pop, swap and pop. Wait, let's print that. Stack underflow. Okay, so it's 0. But if we make R1 0 to start, then yeah, then it just ends. So make it 1. And yeah, so it gets stuck in an infinite loop. So let's print what this is. Yeah, okay. Actually, then we need to move it into the register. Because we're not basing it on the stack. Let's actually, just up here, push R0. And then, yeah, we'll just use it on the stack. So, I think this should be fine. This should just, yeah, there we go. Okay. Let me stack underflow. But, yeah, get stuck in an infinite loop still. But that is better. That is something that was not right. So we get that. So that's, yeah, 10 times 10. Okay. And then when we get here, let me do anything. Okay, then we get 0 on the top a lot. So why is that? So we can push R1 and push 0. And yeah, so compare equal. Let me dupe and print, and then see. Alright, oh, because we don't actually subtract. Oh man, I am stupid. Okay, so we need to subtract from R1. So we can push R1 here, then push 1 and sub, and then we can move R1 top, and then we can pop it off. Okay, there we go. And alright, it's not infinite loop now. Let's print here. 100, okay. And is that all that is on the stack? Okay, it is. So, that's not quite right. Because we want to make this 1. So compare greater. Greater equal. Like that. And let's print this here. Yeah, because we're not actually comparing with 0. So we have 10. Okay, because 10 to the power of 1 is that. How does math work? Okay, well if we make this 2, it should be 100. Okay, and then if we make it 5, okay, I think that is right. Yeah, so, okay, and we can change this. So if we make it 2 to the power of 10, oops, 10, like that, then it will be 1024, and it's not. Okay, so it didn't work. Ooh. Why did it not work? Okay, that's not right at all. Oh, I think we are using the wrong... No, we're not using the wrong registers here. So we push R0. It must get removed from the stack at some point for some reason. Okay. Dupe and print here. And we can look at what happens. So... So we have 4. So, yeah, but then it multiplies it by itself. So that is not what we want. Yeah, because we want it to multiply by the value in the register. So, yeah, we do actually need to... We need to do this. Yeah, it's R0. So instead of dupe, we want to do that, and then do... Okay. There we go. Yes. Alright. So, let me not do this. And it should, yeah, 1024. And we can make this 10 and 2. And it should still be 100. Okay, we'll make it 3 and then 1000. Okay. Yeah, I think that's right. 5 to the power of 3 and 125. Okay. That looks right to me. And there's nothing left over on the stack. And it's all in the registers, the arguments. So that's pretty good, I think. So let me just grab this. And then go to go into here, and I'll put it maybe I'll put it up more towards the top actually, like that, and then we can import that, delete all of this, and then okay, already declared. Okay, but we don't define that up here. So, okay. Yeah, that is interesting. Yeah, I'm not sure what that's about. Yeah, if we put this first, then it breaks. Yeah, that is kind of weird. And that is with the preprocessor because it is opening up there. So that is part of the to do. But we can fix it for now by just putting this first. And that's okay. All right. So, yeah, instead of printing, let's actually let's just call print int like that, and it should print it out. Yeah, and then we can also push a new line, reference it, and then push standard out and write. And there we go, 125. Let me do the same thing for the, what was the one that, was it, string compare, like this. And yeah, so instead of doing this, we will, yeah, so we can do call print int, and then push that. Maybe I should make a function just for printing a new line, because it is just the same thing, like that. So this is string compare. Okay, and it's segfaults. Okay, but then it works fine there. Oh, did I use the wrong... Yeah, I forgot to actually reference it. Okay, So yeah, let me actually make a standard function for that. So this can go at the top because it is like basically just print new line like that. So we just push that, and then we reference, then we push 1, and we do have to pop stuff off though, and then native 1, and I think we can pop. We just do that. Yeah, let me actually call that here. Call print new line, and okay, we get stuck. Because we won't return. Okay. And there we go. And let's see, there shouldn't be anything on the stack. Okay, perfect. Yeah, then we can use that here as well. Call print new line. There we go. And it works. Okay. And we can make this whatever. And 3, and there we go. I think, yeah, 2 to the power of 16. There we go. Yeah. I get 2 to the power of 32. Like that. Yeah. Big number. So let me do, let's see, I want to see a reasonable number. Alright, that's pretty good, I think. So, now we implemented power and print new line. So, that's pretty good. And we can actually use this in the, let's see, it's one of the standard functions. So, pow, we call that something. Actually, it's native something. Standard def. So, power is native 8. Native 8. Yeah, we call that here, but we can just call power. But we do have to move it into the register. So, what is this? 8 power of 10. Actually, let me look in here. Oops. Yeah, close out of this. And then go into here. And let me actually look at my power. No, it is, this is float to, whoops. Float to stir, like this. So, why do we call it on 8 and 10? Let's see. Float Tim. Alright, well, so if instead of doing that, we do call power. It doesn't work anymore. Oh, because that is the after point. Okay. Yeah, so why doesn't... Oh, I think we might need to swap these around, actually. Nope. Oh, because... Ooh. Because it doesn't work with floats. Ooh, okay. Well, neither does that one. So... Yeah. No, we don't actually move it into the register, so that is why. Yeah, I forgot about that. Yeah, so we need to move R010, move R18, and then call out. And there we go, okay. Yeah, that is what we want exactly. So if I open up, print float, yeah, there we go, it's this one. And I can change this. Like that. And then float, and it still works. All right, that is perfect. So now, yeah, now we are depending less and less on the native functions, and that is pretty good, I think. Yep, and all right, so that is, yeah, that's fine. I'll actually change back then. There we go, and yeah. All right, so that works. That is what I wanted. We don't need to pop anything off because we do that. So it's perfect, actually. Yeah. That's pretty good, I think. So, yeah, everything seems to be working. Let me make sure, like this. Yep, okay. So it all works. That is what I wanted exactly. In here, we can also do call print new line. And then we don't have to do all this. And There we go. Okay, perfect. So that is good stuff. Let me commit this stuff. So we added power, and then we also let's see, added power function implementation in Chasm, and added print new line function as well, and updated the result or the examples to use them. Is what we did. All right, so we'll push that, and then yeah, I'll see what else I can implement. Okay. Whenever this decides to work. Okay, and then pretty slow. All right, but all right, perfect. Didn't work. Okay, so test. All right, so let me look back in here. So what other ones? Is there any? Let's see. So malloc, yeah. So these are file stuff like syscalls, and I think that we have to leave those as the native functions. Yeah. Okay, we have all of those ones. Scanf, that is one that I think we can implement just using the read. I didn't want to do that at the time. Time, I don't know how that would work. Exit as well. Well, exit could be halt also, perhaps, technically. Yeah, if we just halt with an operand, but I think, no, no. Okay, we have string compare, so we did that. String copy, we don't have that one. Mem copy, string concatenate. Yeah. Okay. So what other ones could I implement? Because, let's see. Let me do a git clean real quick. And then I will build all the tests and make sure they, okay, they all still compile. That is good. Now, so actually not in here. I want to look in here. Let me look at the native functions. So yeah. So these are all the ones that we're using right now. I think we could probably do malloc as well, like actually implement a memory allocator in our language. That could be interesting in the assembly. I might wait until I actually make the higher level language on top of it to implement that, and then make it part of that standard library rather than using the assembly. Time. I don't know. Like, how do you get the time? That could be. We could try to do random though, like generate random numbers. So, how does random number work? Let me see. Because if I could, yeah, just make random using the time. So calling this native function, and then we generate a random number based on that. Yeah. So I don't know how it works exactly. I mean, we could technically just kind of do random stuff. Well, hang on. Let me, and then, let's see. Actually, let me, whoops. Okay, do we have actually random function? SQLite, alright. Yeah, I don't see it. Because that is, well, actually, it's ran like that, right? And wait for that. Clear. Then run that. Okay. So, turn ran seed. Yeah, okay, alright, let's see, this, yeah, so, uses a seed, we could do one that doesn't use a seed, though, it would just be random every time, so, Um, let's see. Random number in. Let's look in assembly and see, because that one, like, without any. Yeah, let's see. So, if you need one single random number, okay. Let's look at like a random number algorithm. Can we look at something like that? Yeah, not real random, pseudo random. That's how it all is, though. Doo-doo. All right, is there like an implementation? Dang, I can't even read that. Probability, yeah. I just want to try to implement a simple one. Like, it doesn't have to be super complex or anything, but just a simple thing that generates a random number. Okay, what are they? All right. Example algorithm. Accept an initial input. Apply that seed in a sequence of mathematical operations to generate the result. Okay. Yeah. So, modulus is positive. Okay. Multiply it. So here is an implementation in JavaScript. So that is results stored in array. I don't. Okay, so that's the input. So y is less than n. So we multiply, and then you. Okay. Let me try that. So let me just cd test, and then vim random.dash, or no, random.tasm. There we go. So I'll make a main right now, and then I will, let's see. So I'll just use random stuff for this right now. So x0. Okay. So you set x0. So why does it have to be an argv? Yeah, so we won't worry about that. So A, so we just use 1, and then push B, 2, 3, and then the number of iterations will do 5. So, alright, so that is on the top. So we want to push 0 now, and then compare, alright, we want to compare these top two. So if 0 is greater, then we want to, let's see, so if it is greater, we want to keep going through the loop. Otherwise, we want to jump to the end. I think my internet died. Okay, no, it's not dead. Is the stream still alive? Okay, it looks like it's back now. I think it went out for a second though. Okay, so if it is not equal, or if it's not greater, then we want to jump to the end. So this can be, let's call it n for now. N like this. I'll call it random n actually. Rand n. Alright, that's good. Rand n. And yeah, we'll return from there. So otherwise, we want to go through a loop. I actually want to do this comparison. So this is sort of where the loop will start. Rand loop, like that. And then we want to jump to the rand loop. Which there might be another comparison. So then we want to do all this stuff, and then for now I'll just print the integer value that this generates. So this might, it looks like it might be floats is what it's supposed to be, but I'll just use integers for right now. Okay, so in here, alright, so we have all of these. So maybe I'll move them into the registers instead. So move R0 is 1, move R1 is 2, move R2 is 3. Okay, so then when we need them, we can just get them easily. And then this is the number of iterations. So, yeah, so then we need to do A times x0. So we need to actually define x0. So yeah, that needs to be the first one. So I can iterate all these. Then move R0 is, alright, so we'll just do something random. 4. Okay, so we need to do push R1 and push R0, and then multiply them. And then we need to push B, so that is R2. Let me just give names to these so I can remember. This is the X0. This is which one? A. This is B. And then, yeah, this one's N, and that one is N. So, okay. Push R2. Okay. Oh, this actually shows. So that's the modulus. Desired array length. Okay. So that's the seed, actually, is what X0 is. But then we want to replace the value in the register with the output of this at the end. So we push R2, so that is B. And then we add. And then we want to mod all of that by M. So we can push R3 and then call mod. Oops. And then let's actually print what that is. So let me just do entry point main here. Okay, undeclared label. Yep, so that needs an underscore. There we go. Random.tim. Alright, stack overflow. So we go forever and we never actually get here. So, so why don't we ever call print? Yeah, so that, okay. 0 jump to ran n. Okay. But why doesn't it call it here? It doesn't here either. Oh, because we tried to return, actually. And that won't work. Let me make a main, actually, and then actually call this function. Call ran. Yeah, so I'll just call this ran. And there we go. So then we can return, and that's proper. So let's print there now. Yeah, okay, it does reach the end now. So they are, it is that. So that's not exactly what we want. So I think we might need to use that. Okay. It should be stuck in an infinite loop right now, but it's not. Okay, so we have 0 there. Which isn't what we want. But we do get here now. So why does it become 0? So, let's see. So R1 and R0, and we multiply. And then R2 is B, and we add it. And then we mod it by M. So why does that not work? So we have, let's see, 4 times 1 plus 2. So we have that, and then we mod that by 3. So, ooh, okay, that's why it's 0, actually. Let's make it, yeah, okay, let's make it 4 instead, and then it won't be 0 this time. Okay, yeah, so that is what the issue was. So then we can actually move this into, want to move it into R0, and now there shouldn't be anything on the stack, but there is, oh, because we didn't pop it off, actually. So if we do that, okay, and then, yeah, we jump there. So now we just need to iterate. There is stuff on the stack though. Yeah, because that is actually that which we need to iterate. Actually, let me print and then print. Okay. 0 and then 5. So we want to iterate the 5. So we have. Oh yeah, we need to actually pop this off. That is what the issue with that is. So swap and pop. We want to leave the other one on. So there we go. Now we just had the 5. So that is what we wanted. So we can push 1 and then we can sub. And then we want to jump through the loop. Okay. And at the end we can print. And we have 0. So yeah. Ooh, why do we have 0? Oh, because we have that. So yeah, at the end we want to just pop it off. And then we want to actually push R0 and print it. And we got 2. Okay. So, so before we move it there, before we pop it actually, let me just print it right now instead of popping. And then we get 202022. Okay, so if we change out these values, we get something different. Okay. 6. Oh, you know what? We want to actually change it. We want to print it every time. Ooh, we got 7 every time. So that's what we want to do instead of actually moving it into the register. Well, no, we do want to move it into the register and we want to print it out. So, yeah. But I guess that's what we're doing here. Okay, so let's see. A is multiplying. This, okay. This is the number of loops. I'll just get 7 every time. So alright, if we change the seed, it should change that. And it does change that first. Okay. So let's make this 2. And then we get that. And if we change this, it should change every time. Okay, and then we just want to print the int. So let me actually import that. And we want to also import the standard defs. And then I want to print the integer. Here, instead of calling print, I just want to be print int. Oh. There we go. Okay, and then we still have the print at the end. Okay, so we get 53. And if we change this, oops, yeah, we change that, and okay, and it's the same thing. So, alright, well now it's different. So we can also change the length of it by doing that. Yeah, but I don't think I did. I think I did something wrong because we get. Well, that's pretty. So, yeah, I'm not sure what I am doing wrong here. Yeah, but we get that every time. Let me just print new line here, comma. And then, okay, so then we can see it a bit better. Yeah, and we do want, these can stay the same, and then this is just the seed. So let's actually not call this in here. So let's call it here. So let's move R0, 1, 2, 3, sure. And then instead of this, we don't have that at all, actually. And then, yeah, so, yeah, and it's just like the same. So something is wrong in here where it gets stuck on 7. And we can increment this. Yeah, it just gets stuck on 7. So push R1. So in R0 and multiply. Let me just print that. 182. Okay. So let's see what it is through every iteration. 182, 42. Yeah, and then it gets stuck on 98. So then we push that and add. Push that and add, and let me dupe and print that and see what it is. And it's just the same thing on every iteration. Yeah. Actually, let me dupe and print just the R0, and we can see what that is. Yeah, so it just, yeah. Actually, I already knew that because that is what we're printing out anyway. For some reason, it gets stuck on the same thing. Actually, that's printing out the same thing again. So let's do that here instead. Yeah, so it all, well, that's actually supposed to be the same. So, like, converges. So what if I change these up? Then we get that. So that is okay. That is actually fetching something. Let me. So that is the implementation of this. Yeah. So the modulus has to be positive. Okay, that is this. The multiplier is positive but less than the modulus. Okay, so that is B is the multiplier. So that is good still. The increment is non-negative but less than the mod. All right, so this needs to be less than modulus. Okay. Okay, and then the seed is non-negative but less than the modulus. Okay, so yeah, right now the seed is not less than. Okay. So that is a thing. Let me make them bigger values though. So like something like that. And then this has to be, yeah, so they all have to be less than this one. So this can be something like that. Actually, shoot. Yeah, alright, that's fine then. And then we get big number. If I make this 1. Yeah, I think I'll make them a bit smaller than that. Maybe like 50, and then 12, and then 99. So yeah, we still get a pretty big number. Okay, but it looks much more random. That is the seed though. So when we pass the seed, so if we pass the time as the seed though. Actually, yeah, let's make it. Let's see. And then yeah, we get a big number. But we can constrict it. I don't remember exactly how it works. I think it is something like yeah, actually we can't really do that with the way it's outputted. Yeah. Okay. Well, let's try to use the time. So let's call the time function. How does that work exactly? So time needed time like this. And it just pushes it to the top of the stack. Okay. So I think that is 10. Let's just print what it is. And then yeah, so I think that is right. Yeah, alright, so that is actually the time. So then we actually want to move the top, and then that is the seed, but it might be too large. Well, okay. Yeah, well now it's based on the time. That looks pretty random. Yeah, I think that's pretty good. It's not the best implementation, but it does work. So yeah, I'm gonna call that good. Now I will go ahead and commit this. Added random example, which uses the time as, nope, no. I need to actually, random.tasm. I need to move this to the standard library. std. Alright, yeah, and I'll just, put it after power. Actually, yeah, I'll put it like right here. So then it should still work. Let's see. Label ran already declared. Okay. Maybe I'll call it random then. Random. Actually, we still use. Oh yeah. So that is because of the macro, I think. So call random. There we go, and it works. Okay. So, and if you call it fast enough, it's the same thing because it's based on time. So there we go. That is what I wanted to do. Yeah. So I think that is pretty good. Now I can actually. Yeah. Added random function to standard library. and added an example which uses the current time as the seed. And there we go. Okay. And then after I push this, it is going to be the end of the stream. Yeah, so if anyone needs to say anything, now is the time. Okay, whenever this decide, there we go. Okay, yeah, loading, and there we go. All right. So should say, all right, perfect. So it did work indeed. All right, yes. So that is probably going to be about it. So assuming nobody has anything to say or any questions or anything like that, I'm not seeing anything. Okay, yeah, it looks like we are good. So, yeah, so that is going to be the end of the stream, I suppose. Let's see, maybe we can do a raid. Zig Day. Do you guys like Zig? Yeah, actually, let me move this over here. There we go. MetaMe is live right now. Doing Zig. So I will raid that, and then we're good to go. So let me unpause that. There we go. And whenever it loads, it's gonna be hard to watch it though. Okay. And everyone left, so there we go. And raid. Alright. Whenever it goes.